Welcome to ZT online course. I'm the lecturer of this course, Zhang Dong. This course is CSFB voice solution. Let's see the contents of this course. From this course, we will study four parts. The first part is introduction to LT voice solution in the industry. The second part is basic principles of CS fallback. The third part is the CS fallback flow. The last part is the key technologies of CS fallback. Okay, let's see the first part, introduction to LT voice solution in the industry. And we can see in LT network, compared with the 2G and the 3G network, we delete CS. We only have PS. PS means packet switch and CS means circuit switch. And as we know, in 2G and 3G, voice is a CS, data is a PS. But in LT network, we only have PS. So that means in LT network, we don't have CS voice. So if we want to support the voice, how to do it? Okay, so we can use CS fallback solution. But CS fallback, that means if the UE want to set up a call in LT network, it need to fall back to 2G and 3G network. So in this way, it will increase the time delay. So how to solve this problem? This we will discuss in this topic. And we can see the impact of LT wireless deployment on existing CS network. And the 3GPP has already determined the technology between LT and the 2G, 3G system should be the single radio technology. So what is a single radio technology? Single radio technology, that means LT and CS. We can also say PS and CS cannot be used at the same time. Okay, cannot use at the same time. So that's why when you want to set up call, you need to from LT fall back to the 2G and the 3G network. So in this way, the PS service, it will be interrupt. Okay, interrupt. Okay, when we can see the impact of LT network deployment on voice service in different stages. You can see there's 4 different stages. In phase 1, we can see this is poor data card phase. So in this phase, the mobile broadband, also like the data services, only provided by data card. This is the initial. This is the initial stage in LT network. Okay, in the phase 2, we can see this is a mobile internet phase. So in this phase, we have CS fallback solution. So that means the terminals can support PS and CS, but cannot support PS and CS together. That means if the user want to make voice services, okay, they need to fall back to the 2G and the 3G network. Okay, the third phase. Phase 3 is LT voice and multimedia introduction phase. So that means in this phase, in LT network, we deployed IMS system. IMS means IP multimedia services. So that means LT can provide a voice. So this voice we named VoLTE, VoLTE. But in this phase, the LT coverage is not big. That means the LT network cannot coverage most areas. So that means when the UE set up call, but the UE moved to the 2G and the 3G network, we also need some interconnection between 4G and 2G and 3G network. So these technologies we named SRVCC. That means single radio voice call continuous. Through this technology, we can guarantee the call continues between 4G network and the 2G and 3G network. Okay, the phase 4. Phase 4, that means the LT network has already covered most areas. So in this phase, CS no need. We can remove all the CS network, just provided by the PS. So we can also say just supported by the VoLTE technology. Actually, now in China, the most areas has already supported by the VoLTE, just like phase 4. Okay, and for this topic, we just talk about phase 2. Phase 2, that means 4G network cannot provide voice. So if the UE want to set up a call, they need to fall back to the 2G and 3G network. Okay, we can see the LT voice solutions. From this slide, we can see there are the 3 solutions. The first solution is like SGLT. SGLT just like LT and GSM together. We can also say just like multi-mode dual standby. We can also say for the UE, for our terminals, it will insert 2 SIM cards. One SIM card support PS, one SIM card support CS. One SIM card support LT, one SIM card support GSM for voice. So this is a dual standby. Okay, and in the second solution is the CS fallback solution. So that means our UE just insert one SIM card, and this SIM card can support LT and 2G and 3G, but cannot support at the same time. So that means if the UE set up call, the voice services will provide by the 2G and the 3G network. So in this solution, we need an interface between LT network and the 2G 3G network. And this interface we named SGS interface. Okay, so because of the SGS interface, we can support CS fallback technology. Okay, the last solution is VoLTE plus SRVCC based on the IMS solution. So in this solution, the LT core network, we should deploy IMS system. Because of the IMS system, the LT network can support voice by itself. But if the UE from LT network move to the 2G or 3G network, how to guarantee the voice continues? So in this solution, we also have SRVCC technology. SRVCC means single radio voice call continuous technologies. So in this solution, we also need an interface between LT core network and the 2G and the 3G core network. And this interface we named SV interface. So please remember, if we want to support CS fallback, we need SGS interface. If we want to support SRVCC, we need SV interface. And this slide, we are talking about the second solutions, CS fallback solution. Okay, now let's see the second part, the basic principles of CS fallback. So what is CS fallback? CS fallback means circuit switch fallback. So that means this technology support voice, and the voice actually is still supported by the traditional CS network. CS network. So when the UE initiate the voice services, the EPS means the LTE core network will instruct UE fall back to the CS network. CS network just like 2G and 3G network. Okay, initiate the voice call, and after the call, the UE can go back to the LTE network. And this is a single standby UE. Single standby just like only insert one SIM card. Okay, one SIM card. So the UE can fall back to the CS domain through the fallback technology. And for the data service, no need to fall back. So the data service here carried by LT. But when you fall back to the 2G and 3G network, for data services also will be stopped. Yeah, it will be stopped. Only after voice finish, you can continue the data services. Okay, and for the short message also no need to feedback. The short message can rotate to the LT network through the SGS interface. So this interface, SGS interface, is very important in the CS fallback. Okay, we can see this CS fallback procedure. We can see totally there are 4 steps: 1, 2, 3, and 4. Okay, the first step is the UE initiate. The UE initiate a calling voice services, right? The UE initiate the calling voice services. Okay, if the MME receive the calling voice services request, the second step is the MME will instruct the E node B to drop UE back to the 2G and 3G network. Okay, and the third step is the E node B takes UE back to the GSM and UMTS network according to the UE capability. So the last step, the UE initiate calling voice services on the 2G and 3G network. Okay, so this is the procedure of CS fallback. Okay, we can see the CS fallback network architecture, and here is 2G and 3G network, and here is LT network. So we just pay attention. They have an interface between MME and MSE. This interface is SGS. Because of SGS interface, the CS fallback can realize. Okay, CS fallback can realize. So the prerequisite for the CS fallback technology, SGS interface. So what's the function of SGS interface? The first function, because of SGS interface, the UE can realize the combined, attach, and the location update. So that means when the UE log in the LT network, when the UE log in the LT network, of course, he need to attach LT network and the tracking area update in LT network, right? And because of SGS interface, the UE also can complete the 2G network or 3G network attach and the location update. So this can save the resource. And the second function of SGS, it is can realize the short message reception and sending. So that means because of this interface, for short message, no need to fallback. This is a second function. The third function is the pages called parties in voice services. So that means the UE can fallback the related MS registered in the combined location and attach update. Okay, so this is the the 3 functions of SGS interface. So we can compare between these 3 CS fallback solutions. Okay, the first solution, just like we just upgrade the 2G MSE, and then we create a new interface between MSE and EPC. In this way, if the UE want to set up call, he can from MME directly fall back to the MSE. Okay, and in this way, the delay is about 2 seconds. And the second solution, we can see we can deploy a new MSE. Just for the CS fallback. So that means when the EPC, when the 4G setup call, he through the SGS interface fall back to the new MSE for the call. And then for the new MSE for the call and communicate to the original MSE and then to find the called UE. So in this way, the call delay it will more than the first solution. Is normally is more than 2 seconds. Okay, the third solution. The third solution we can see, we are constructing a new proxy MSC. Okay, the proxy MSC. So the proxy MSC also can build and also can be built to support the voice services, and it can reduce the upgrade the cost, right? And in our network, we recommend the first solution. If the resource for upgrading the real network are not available, so that means because this solution, the MSC also need to upgrade. If it's not available for upgrade MSC, okay, we recommend the third one, okay, because third one just like a proxy, okay, the proxy. But the second one we can see the delay is increased, but the second one it can involve the capacity expansion, okay, the capacity expansion. But the engineering execution is difficult, okay, is difficult. Okay, so this is the basic principles of CS fallback. And now let's see the third part is a CS fallback flow. And as we know, because of SGS interface, the UE can do the combined attach and the combined update. So how to realize the combined attach? It has a 3 steps. The first step is the UE attached to the LT network, right? So at the beginning, the UE will attach to the LT network, and also there has a one parameter is a combined attach. This is a carry the attach request, and through the SGS interface send to the 2G 3G MSC, and through the 2G 3G MSC send to the HAR to do the combined attach. So that means later when the UE fallback through the MME fallback to the MSC, no need to attach again, right? Attach again. And this is the combined attach signal flow. You can see the first step, the UE will attach the MME, and from step 3 to step 16, this is the LT attach procedure, okay, attach procedure. And then the LT MME will through the SGS interface connect to the 2G and 4G MSC and VAR to do what? To do the combined attach. Okay. So number 3 and number 4 is a combined attach. After that, the MSC and the VAR will feedback the response. That means okay, combined attach finish. After finish, and then if the UE has some paging, the 2G and 3G core network also can be sent. And the second is the combined location update. I think this procedure is similar like before, also through the SDS interface. After UE do the location update in LT network, he also can through the SGS interface to do the location update in 2G and 3G network. And this signal flow is also similar like previous signal flow. The first is location update. This is the tracking area update request to the new MME, right? Because he want to update a new MME. After that, the new MME will send location update request to the MSC VR. So this procedure just realize the combined location update. After that, the MSC and the VAR feedback the location update accept to the new MME, and then the new MME feedback the TAU accept. So after UE send TAU complete, that means the combined location update also finish. So later, if the user has some paging, the MAC and the VAR also can send the paging request. And the third is the CS fallback calling flow. Calling flow. The calling flow you can see it has a first is a LT call origination, right? Before the origination, first the terminal should be attach request to the MME, attach request to the MME. After attach request to the MME, the next like this procedure you can think just like combine attach and combine update. Okay, after combine attach and combine update, the camp on LT and 2G 3G registration finish. Now the UE has already registered in LT and 2G 3G network. Okay, the next, if the UE has some call, if the UE has some call, okay, he will send the CS fallback call request to the MME, right? He will send the CS fallback call request to the MME. If the MME receive the CS fallback call request, okay, he will do the fallback indication. And how to fallback? For example, how to fallback to 2G and 3G? They have the three solutions. The first solution we can use a handover, PS handover, fallback to the 2G and 3G. The second is CCO. CCO means cell change order with NACC is a network assisted cell change. So the second solution is only happening between LT to 2G network. Okay. The third solution is RC release. Through the RC release message, we are carried some SIP information and UE fallback to the 2G network. Okay. After fallback to 2G or 3G call network, okay, the call will be set up in the 2G and the 3G network. And after the call finish, the UE will do what? He need to go back. He will need to return to the LT network, right? So the third is reselect the LT the network. After reselect, the UE will return to the LT network. So also we have a technology named fast return. So for the next page, we will study the fallback technologies and return technologies. So this is the CS fallback calling flow. Okay, this is the same like a previous slide, but this is just more in details to explain. Okay, this is the CS fallback call flow. Call flow just like the UE first need to receive the paging message, right? We need to receive the paging message. After receive the paging messages, the UE will send the access request. Okay. After access request, the next is the same. Is the voice fallback indication and voice fallback response. And also for the after voice fallback indication and the voice fallback response, the UE will fallback has already fallback to the 2G and 3G and can set up call. After the CS call, the UE will return to the LT network. So for the next question is similar like previously. And also they have some technologies like MTRR and MTRF. These two technologies we will also introduce to the next pages. Okay, and this is the CS fallback call flow in adder mode. In adder mode, just like the UE first receive the paging, because adder, so the UE can receive the paging and then send access service request. And after that, it will initiate the services. And this is the CS fallback call flow in activated status. So that means now the UE has do some PS services, do some LT data services, but now it has some paging request. So after that, after UE receives the paging messages, the UE will interrupt the data services and then fall back to the 2G and the 3G network and set up the call. After the call finished, will return to the LT network. And this is a CS fallback short message over SGS flow. From the previous slide, we have already mentioned short message. For the UE for short message, no need fallback because of the SGS interface. So that means if the UE want to send a message to another UE, how to do it? Okay, the UE will send short message to his MME and through the SGS interface send to the MSC1 in 2G and 3G network, and MSC1 will send a message to the short message center. Short message center will send a message to the target gateway MSC, and the target gateway MSC will send this message to the HAR, okay, to looking for the target MSC2 address. Okay, HAR will feedback the MSC2 address, and then the GMSC can find the MSC2. Okay, and the MSC2 will send the message to the another MME. Okay, through the MME sent to the. So we can see because of the SGS interface, the short message can support in LT and 2G network. Okay, this is the short message flow. In MO. MO means the mobile originated short message flow. The user is in idle mode. And this is the mobile terminated short message flow in idle mode. Okay, so this is a CS fallback flow. Now let's see the fourth part, the key technologies of CS fallback. There are 4 technologies we introduced. The first is the call setup delay. As we know, the user fallback and the location update process always increase call setup delay, right? So we can see the original fallback. The original fallback is like if the UE, okay, in LT network where the call origination fallback process initiation, okay, and fallback to 2G network and synchronize with 2G and 3 selected, and then read the 2G and 3G system broadcast, and then he can initiate the services. So you can see in this procedure, the delay is about 3 seconds. Especially the read the 2G cell system broadcast, it costs 1.83 seconds. So how to do it? You can see we can optimize the process. How to optimize? You can see during the LT user originated fallback process initial, he will obtain the LT enable cell system broadcast at the same time. So you can just like this procedure, it will move to here process. So that means this procedure, it can process in advance. So that means later in here, we can save 1.83 seconds. Okay, 1.83 seconds. So after this process, the delay, it will reduce 1.83 seconds. Okay. And the second technology is a fallback solution. And from the previous slide, we know there are 3 fallback solutions. The first is PS handover. The second is CCO, it's NACC. The third solution is a RC release solution. For the PS handover, you can see the delay, it will increase 2 to 4 seconds. Why? Because you know in handover there are the 2 steps. There are the 3 steps. The first step is a handover preparation, and the second step is a handover execution. The third step is a handover completion, right? And we know during the handover preparation and handover execution, this takes long time. Because the source site should communicate with the target site. So the delay is very, very longer. And we can see that because this is the handover between different systems, between different technology. So if we realize the PS handover, it will involve the NLB, MME in LTE network, SGSM, BSC in 2G network. So this is very complicated solution. Okay, the second solution is a CCO with NACC. CCO means cell change order. Okay, cell change order. And NACC means network assist cell change. Okay, and this solution is only happened between LTE network fallback to 2G network. Cannot support LTE network fallback to the 3G network. And CCO, there are two. So there are two options. The first option is without. The second is with. Normally we select with because with NACC it can reduce time delay. Okay, time delay. Okay, the third solution is RC released. So that means when the UE start the CS back, okay, the NLB it will release the RC message. But in this RC release message, it will include the neighbor cell information. Just like when the UE receives the RC relief message, the UE will understand, okay, which target cell I will going to, and the UE will go to the target 2G or 3G cell to do the initial access. Okay, so this solution is also named redirection. Okay, this is a redirection solution. Okay, the third technology is the cord party failure problem. So what is cord party failure problem after CS fallback? Because we know during the combined location update, that means the UE will update in 4G network and the 2G, 3G network, right? So the MME will designate SGS MSC to UE through the TM and LA. But normally in the MT calling flow, and also we can see during the calling, the UE is moving, right? So after moving, the UE may be moved to a new location area, or it will move to a new location area with a different MSC. So the cord party failure will be caused. For example, in scenario one is a normal scenario. Normal scenario that means during the LT, during the combined location update, the enemy has already designated this LA1 to the UE. So after fallback, the UE just fall back to the same LA1. So it doesn't matter. But you can see in the scenario 2, it has a problem. So what's the problem? At the beginning, the LT designated the L1 is for the combined update, but during the fallback, the UE fall back to the LA2. This LL2. So the UE need to from LL1 update to LL2 again. So the delay it will be increased. But you can see in this way, LA2 and LL1 they belong to the same MSC. The third we can see also the UE after fallback will fall back to the LA2. But we can see LL2 is belong to MSC2, but LL1 is belong to MSC1. So they are belong to different MSC. So in this way is abnormal scenario. So this is the party failure. And here also explain the party failure problem after CS fallback. So we can see here, in this area, the pink color is TA, the white color is LA. So we can see the same TA, but across to the different LA, right? So the MSC is different after fallback. After fallback. For example, in this area, TA2 is LA6. LA6 belong to MSC2, but in this area is LA2, but LA2 is belong to MSC1. So they are different. They are different MSC. So this is a cold party failure. And the failure scenario 2, you can see this area. This area, that means the MSC have overlapped wireless coverage. The MSC1 and the MSC2 with the same coverage. With the same coverage. So this also has the cold party failure. So how to solve this problem? We have two technologies. First is MTRR. Second is MTRF. MTR, just like after receive the call failure message, the UE will indicate the call retry. Okay, the call retry from the specific MSC. The calling end office initiate the call request again. So during this request, the user has completed the location update. Okay, and the user MSC registered a new MSC. The call will succeed. So this is MTRR flow. The call forwarding solution is MTRF also. The original MSC received the call request after paging fail. The original MSC doesn't release call, but forward call to the new MSC. The original MSC obtain address of the new MSC and update flow. So this is a MTRF flow. So we can compare with these two technologies. The reconstruction between these two technologies and the network planning and the maintenance, and the 3GPP standard and device supported and user experience calling so you can see the differences between these two technologies. Okay, last technology is the user is unreachable during the return to the LT network after call completion. The problem is after hang up within the 2G network, the UE have to read the 2G broadcast update LA and routing area update and measure the LT neighbor cells and then return to the LT. So in this procedure, it takes a long time. So it takes a long time, it will affect the user experience. So how to do it? Okay, we are using the one hook and return solution, faster return. Okay, we can see these two solutions. The first solution is the original solution. You can see after hang up, the user will fall back and then he will read the GSM network broadcast and the location update, routing area update, and then fall back to the LT and return to LT. So this takes a long time. Okay, we can see in here, this procedure, we just move the number 3 procedure to the second procedure. So that means the second procedure and the third procedure, they are together. So that means after hang up the UE, no need to read the GSM network broadcasting and the location area update and routing area update. The UE just directly read the LT neighboring cell information and to do the fast reselection. And then the UE can fast return to the LT network. So because of this technology, it can reduce 1 and 2 seconds in theory. Okay, so that's all for this topic. Thanks for your learning.